Question 1 from the 2022 National 5 Physics paper from the SQA. Which of the following contains one scalar quantity and one vector quantity? Well, let's refresh our minds by looking at a table of scalars and vectors. Remember, a scalar has just got a magnitude only. It's a quantity. It just needs a number to describe it, magnitude. And vectors, they're a special quantity that needs magnitude and direction to fully describe them. And there's a table there. So in part A, letter A, we have the following. We have got acceleration and displacement, and acceleration and displacement are both vectors, so we can rule that one out. B, kinetic energy and speeds. Well, anything to do with energy is a scalar quantity, and speed is a scalar quantity, we can see from the table, so that's ruled that one out. Letter C, velocity and weight. Well, velocity is a vector quantity and weight is also a vector quantity because it's related to force. So that is out as well. Letter D, potential energy and work. Well, potential energy is an energy, which is a scalar, and work done is also to do with energy, and that's a scalar. So we've lost our first four responses. And the last response, distance and force, well, that's the correct response because distance is a scalar and force is a vector. So learn those scalars and vectors. Question 2 from section 1 of the 2022 National 5 Physics exam. The diagram shows a toy car at rest at the top of a slope. The car is released and travels with a constant acceleration down the slope. I'm being asked to find which row in the table could show the speed of the toy car at P and the speed of the toy car at Q and the average speed of the car between P and Q. Well, the car is setting off from rest in this position here, so the velocity or the speed of the car is going to be 0 here. And as it moves down the slope, it's going to increase its speed. So obviously the speed at P is not going to be equal to 0, so we can rule that one out right away. So response A is out, because the car will have a speed at position P. Now, if the car is accelerating downwards, it means that the speed at P and the speed at Q will be different. The speed at Q will be greater than the speed at P. So 1 and 1, that rules that out because that means the speed is not increasing, it's just staying the same. And the car is accelerating. The rest of the responses, well, they seem correct because the speed at P is 1 and it's increased its speed to 3 at Q. And speed at P is 2 and it's increased its speed to 3 at Q. Speed at P is 2 and it's increased its speed at Q to 3. So these next three responses are correct. It's the response to do with the average speed between P and Q. So how do we find the average speed of an object when we know it's two speeds? Well, we just rely on the starting speed, so we'll call that U, and we add on the final speed, which we'll call it V, and we just divide by 2. That's all we do to get the average speed. Take the two speeds, add them together, and divide by 2. So if you look at response C, we have speed 1 at P is 1 and speed at Q is 3, so we add them up and we're going to have U plus V. 1 plus 3 is going to give you 4, and we're going to divide that by 2, so that's going to give you 4 divided by 2, which is going to give you 2 meters per second. So the average speed there is 2 meters per second, so that could be a possible winner, that one there. We know this one's wrong because we've got 2 plus 3 to give us 5, divided by 2 is not going to give us 2, it's going to give us 2.5. 2 plus 3 is 5 again, and divide that 5 by 2, and we're going to get an answer of 2.5. We're not going to get 4 for that one. So that's the answer to this one. It's the answer C for this one. The speed at P is 1 meters per second. The speed at Q is 3 meters per second, and to find the average speed, we've just worked out there, the average speed is the starting speed, whatever it is, plus this final speed, and we divide by 2. So 1 plus 3 is 4, 4 divided by 2 is 2, and that's going to give us an answer of C. Question 3 from the 2022 National 5 Physics exam, section 1. The graph of speed V against time t represents the motion of a cyclist over a 20-second period. I'm being asked to find the distance travelled by the cyclist in the 20-second period. Well, to find the distance gone using a speed time graph, all we have to do is find the area of the graph. So we have to divide that graph into areas that we can work out, like triangles and rectangles. So looking at the graph, I would place a little line across here to give us a rectangle at the bottom, a triangle on top of it, and a bigger rectangle on the right hand side there. So all we have to do is work out the area here, and the area for the first part, we can work it out, is going to be 8 times 4. That's a rectangle of 8 along and 4 up, so 8 fours are 32, so that's going to give you 32 of an area in there. This triangle here has got a base of 8 and a height of, be careful, it's got a height of 6 because it's going from 4 to 10, 6. So we're going to have a little triangle there of 8 and 6 height. So 8 sixes are 48, and a half of 48 is going to give you 24. So that area in there is going to be 24. So now we've got the two areas there. I'll just take this one out to make it neater. We've got the two areas, and we've just got this rectangle part here to work out. It's 8 to 20, which means it's got a length of 12, and it's got the height of 10. So that area in there is going to be 120. So the total area of the graph we can now work out as follows. The total area is going to give us 24 for the triangle, plus 32 for the rectangle, and again 120 for the bigger rectangle. So we add it up, we get 6, 5, 7, and we get 1. So the area is 176, and therefore the distance travelled has got to be 176 metres. So our answer for that is going to be D, 176 metres.